Hello everyone, this is Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equations. So let's get going. Problem. Solve d square minus 4d plus 4 into y equals to 8x square plus e power 2x. So firstly, let's find the order and degree of the given differential equation. Identify the higher derivative. Here d square is the higher derivative, so our order will be 2. And highest power of the highest derivative is that degree is 1. Or just write the given differential equation as d square y minus 4dy plus 4y equals to 8x square plus e power 2x. We know that d is a differential operator. Then d square will be d square by dx square. Now we can write the given differential equation as d square y by dx square minus 4 into dy by dx plus 4y equals to 8x square plus e power 2x. Here d square y by dx square is the highest derivative, so our order will be 2, and highest power of the highest derivative is a degree is 1. Now coming to the problem. Given differential equation, d square minus 4d plus 4 into y equals to 8x square plus e power 2x, which is an operator form. F of d into y equals to q, where f of d equals to d square minus 4d plus 4 and q equals to 8x square plus e power 2x. Now let's find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is a complementary function, yp is a particular integral. We'll find complementary function using the roots of auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Okay. By putting RHS to 0, we'll get f of d into y equals to 0, which is a homogeneous equation of the given non-homogeneous equation. And we'll find yp using 1 by f of d into q. Right? So now let's find yc. Firstly, we'll find yc and later we'll find yp. We know that the auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we have f of d square minus 4d plus 4, right? Let's replace the differential operator by m, so that we'll get f of m equals to m square minus 4m plus 4. Then our auxiliary equation becomes m square plus 4m plus 4 equals to 0. Right? We can write this minus 4m as minus 2 into m into 2 and this 4 as 2 square. So this is of a square minus 2ab plus b square, which is an expansion of a minus b whole square form. Right? Now we can write m minus 2 whole square as m minus 2 into m minus 2. Equate each factor to 0. When m minus 2 is equals to 0, we'll get m equals to 2. Right? Since m minus 2 is repeating twice, so we'll get m equals to 2, 2. That is 2 equal roots. We know that when 2 equal roots, say m1, m2 are equal, then our complementary function will be, since we are having 2 equal roots, so we'll get 2 terms under brackets into e power that equal root into x. Right? Therefore, m equals to 2, 2 are the roots of our auxiliary equation f of m equals to 0, which are equal. Right? So our complementary function looks like yc equals to c1 plus c2x into e power equal root into x, right? Then yc equals to c1 plus c2x into e power 2x. Now we got yc. Now let's find yp, particular integral. We can find particular integral using 1 by f of d into q. We have f of d and q, where f of d is d squared minus 4d plus 4 and q is 8x squared plus e power 2x. Right? So this equals to 1 by d squared minus 4d plus 4 into first term plus 1 by d square minus 4d plus 4 into e power 2x. Again, we can write the first term as 8 into 1 by f of d into x square plus second terms remains the same, d square minus 4d plus 4 into e power 2x. Now we'll find each term under brackets separately. Okay. Now I'll go for 1 by f of d into x square. Here we have this in 1 by f of d into some x power k form, right? So we can write 1 by f of d in 1 by 1 minus x form or 1 plus x form by taking lowest degree term common from all the terms of denominator. Okay, you can just take 4 common from all the terms. Okay, so what I'll do is I'll just multiply and divide 4 to the first two terms. 4 by 4 into d square minus 4d plus 4. See, already we have 4 here, but still we are multiplying, dividing 4 to the first two terms because we are trying to write 1 by f of d in 1 by 1 minus x or 1 by 1 plus x form. Okay, into x square. Now take 4 common from these two terms. We'll get 1 by 4 times 1 by 4 into d square minus 4d plus 1 into x square equals to 1 by 4 into 1 by 1 into d square minus 4d is d square minus 4d by 4 plus 1 into x square. Again, you can write this as 1 by 4 into 1 by 1 plus d square minus 4d by 4 into x square. See, we got 1 by 1 plus d square minus 4d by 4, which is of 1 by 1 plus x form. Right? Now we can write this as 1 by 4 into, we know that 1 by 1 plus x can be written as 1 plus x whole inverse. Right? So we can write 1 by 1 plus d square minus 4d by 4 as 1 plus d square minus 4d by 4 whole inverse into x square. Also, you can write this fraction in 1 by 1 minus x form. Okay, simply you can replace this term as minus 4d plus d square by 4, or this term. You're having d square minus 4d by 4, right? You can write this as minus 4d plus d square. Now take minus common, then we'll get minus of 4d minus d square by 4. Then 1 plus d square minus 4d by 4 becomes 1 minus of 4d minus d square by 4. Right? Then this total fraction becomes 1 by 1 minus 4d minus d square by 4. So this is of 1 by 1 minus x form. So we can write this as 1 minus 4d minus d square by 4 whole inverse. Right? Now we got the first term equals to 1 by 4 into 1 plus d square minus 4d by 4 whole inverse into x square. Now we'll expand 1 plus the term in d whole inverse using 1 plus x whole inverse expansion, binomial series expansion, 1 minus x plus x square minus x cube plus so on. Okay, before heading to this expansion, we'll find derivatives of x square. Derivative of x square is 2x and d square of x square is derivative of x square, right? Then we'll get, already we have the value of d square, derivative of x square, which is 2x. Now find derivative of 2x, we'll get 2 into derivative of x. We know that derivative of x with respect to x is 1, so we'll get 2, right? Again, find d cube of x square is derivative of d square of x square. Since d square of x square is a constant, so derivative of a constant is 0. So from here we'll get all derivatives 0. All derivatives of x square is 0. Right? In general, we can write it as d power k of x square is 0 for k equals to 3, 4, 5 and so on. In our problem, we are having x square, right? For k equals to 2, we'll have only derivative still d square. Okay, here we are having x square, so we'll get the values of derivative still d square. And after d square, d cube, d power 4, d power 5 will be 0. Now, keeping these derivatives in mind, we'll expand 1 plus d square minus 4d by 4 whole inverse is equals to 1 minus x, for x equals to d square minus 4d by 4 plus x square by 2, d square minus 4d, so not 2, just x square, right? Minus, plus and so on. Okay, now let's expand this. We'll get 1 minus d square minus 4d by 4 plus expand d minus 4d whole square, right? Here we'll get d square minus 4d whole square by 4 square, right? Minus, plus and so on. So what we'll get here? This is equals to 1 minus d square minus 4d by 4 plus expansion of d square minus 4d whole square is d square whole square. Just d power, we know that a power m whole power n equals to a power m into n, right? Then d square whole square will be d power 4. So firstly you will get d power 4 plus 4d whole square. 4d whole square is 4 square into d square. 4 square is 16, so we'll get 16d square, right? Next, minus 2 4s are 8. 8 d square into d, which is equals to 8 d square into d power 1. Add the powers, we'll get d cube. Okay, minus 8 d cube. By 4 square is 16, right? So we know that higher powers, d square of x square is 0, d power 5 of x square is 0, also d cube of x square is 0. So from this term we can eliminate or omit d power 4 and d cube. Higher derivatives from d cube can be eliminated, right? Now let's see what happens here. This becomes 1 by 4 into expansion of 1 plus x whole inverse is 1 minus d square minus 4d by 4 plus d square minus 4d by 4 whole square minus so on, right, into x square. Here we have used 1 plus x whole inverse formula, which is equals to 1 minus x plus x square minus x cube plus so on, right? This becomes 1 by 4 into 1 minus d square minus 4d by 4 plus d square minus 4d whole square by 4 square minus so on into x square. This equals to 1 by 4 into 1 minus d square minus 4d by 4 plus expansion of a minus b whole square is d power 4 plus 16d square minus 8d cube by 4 square 16 minus so on into x square. Since d cube of x square equals to 0, d power 4 of x square equals to 0 and so on, d power k of x square equals to 0 for k equals to 3, 4 and so on. So neglect higher derivatives from d cube, d power 4 and so on, right? So we can neglect d power 4 and d cube. Okay, we are going to remove this then. And also the terms from here. We can neglect all the terms from here because here we are going to get whole cube. Okay, that means d square minus 4d by 4 whole cube, d square minus 4d by 4 whole power 4. Always will get higher derivatives from here. We'll get definitely higher derivatives which involves d power 4, d power 5 and so on. Okay. Now let's write this term by neglecting higher derivatives. This is equals to 1 by 4 into 1 minus 1 by 4 into d square minus 4d plus 1 by 16 into, now by neglecting d power 4 and d cube we'll just write 16d square into x square. Okay, we have removed all the higher derivatives from d cube, d power 4, d power 5 and so on, right? Fine. This is equals to 1 by 4 into 1 minus 1 by 4 d square, minus into minus plus 1 by 4 into 4 is 4 by 4 d plus 16 by 16 d square into x square. 4, 4, 16, 16 gets cancelled. This becomes 1 by 4 into 1. Now write the term involving d, just d. So plus d plus terms involving d square. 1 minus 1 by 4 into x square, right? 4 by 4 is 1 and here 16 by 16 is 1, right? Now it's easy to write this step. Now find 1 minus 1 by 4. Simplify 1 minus 1 by 4 is equals to 4 minus 1 by 4 which is equals to 3 by 4. Now we can write this as 1 by 4 into 1 plus d plus 1 minus 1 by 4 is 3 by 4 into d square into x square. This becomes 1 by 4 into 1 into x square is x square plus derivative of x square plus 3 by 4 into d square of x square. This becomes 1 by 4 into x square plus d, derivative of x square is 2x plus 3 by 4 into d square of x square is 2. 2 ones are 2 twos are. This is equals to 1 by 4 into x square plus 2x plus 3 by 2. Therefore, 1 by d square minus 4d plus 4 into x square is 1 by 4 into x square plus 2x plus 3 by 2, right? We can solve like this, or we know that d square minus 4d plus 4 is d minus 2 whole square, right? Now, take minus 2 common from d minus 2. We'll get minus 2 of d by minus 2. Okay, we'll show you clearly. I'll just write the same step. D minus 2 whole square into x square. Now what I'll do is, I'll just multiply and divide minus 2 to this d. Then I'll get minus 2 by minus 2 into d. And I'll write this minus 2 as plus of minus 2. Okay, it's clear, right? Minus 2 gets cancelled and you'll get d. Plus 2 minus is minus. Whole square into x square. Now it's easy to take minus 2 common from these two terms. We'll get 1 by minus 2 into d by this minus 2 plus 1 whole square, right? This whole square. Now we can write this as split the fraction otherwise. Okay. Firstly, let's write this as 1 by minus 2 whole square into d by minus 2 plus 1 whole square into x square. This is equals to 1 by minus 2 whole square is 4 into, we can write d by minus 2 as minus d by 2, right? Plus 1 whole square into x square, which is equals to 1 by 4 into, we can write some x plus 1 as 1 plus x, right? Whole square into x square is equals to 1 by 4 into 1 by 1 plus minus d by 2 whole square x square is equals to 1 by 4 into 1 by 1 plus into minus is minus d by 2 whole square into x square, right? Now this fraction is of 1 by 1 minus x whole square form, and we can write it as 1 minus x power minus 2. Now this becomes 1 by 4 into 1 minus d by 2 whole power minus 2 into x square. We know that 1 minus x whole power minus 2 expansion is 1 plus 2 into x 2x plus 3x square plus 4x cube plus so on, right? Now let's expand 1 plus d by 2 whole power minus 2. Keeping our derivatives in mind. Okay, this is equals to 1 plus 2 into d by 2 plus 3 into d by 2 whole cube plus 4 into d by 2 whole power 4 plus so on. This is equals to 1 plus 2 gets cancelled, you'll get d plus 3 into, sorry, here you'll get d square and this is cube. Okay, 4x cube 3x square, right? D square by 2 square is 4 plus 4 into d cube by 2 cube is 8 plus so on. We know that higher derivatives of d cube of x square, d power 4 of x square is 0, right? From here we'll get derivatives 0. So we can neglect higher derivatives from x cube. So we can neglect all the terms from here. So we can take only the first 3 terms. Right? Now this becomes 1 by 4 into expansion of 1 minus d by 2 whole power minus 2 is 1 plus 2 into d by 2 plus 3 into d by 2 whole square plus 4 into d by 2 whole cube plus so on into x square. This becomes 1 by 4 into 1 plus 2 gets cancelled, you will get d plus 3 into d square by 2 square is 4 plus 4 into d cube by 2 cube is 8 plus so on into x square. Since higher derivatives d power k of x square equals to 0 for k equals to 3, 4 and so on. So neglect d cube, d power 4 and so on. Right? Then this becomes, we are going to neglect all the terms from here. So we'll take only the first 3 terms and we'll get 1 by 4 into 1 plus d plus 3 into d square by 4 or 3 by 4 into d square into x square. Then this becomes 1 by 4 into 1 into x square is x square plus derivative of x square plus 3 by 4 into d square of x square, which is equals to 1 by 4 into x square plus derivative of x square is 2x plus 3 by 4 into d square of x square is 2. 2 ones are 2 twos are. So this is equals to 1 by 4 into x square plus 2x plus 3 by 2. You'll get the same answer. Okay. Now let's find 1 by 4 into e power 2x. This of 1 by f of d into e power ax form for a equals to 2. We have f of d equals to d square minus 4d plus 4. Now let's find f of a is equals to f of 4 equals to 2. We need to find f of 2. Just replace d by 2. Then we'll get 2 square minus 4 into 2 plus 4. 2 square is 4 minus 4 twos are 8 plus 8 which is equals to 4 plus 4 8 minus 8 which is equals to 0. Always remember that the denominator must be non-zero by replacing d with this 2. Okay. But here by replacing d with 2 we got 0 in the denominator. We know that 1 by 0 into e power 2x is undefined because 1 by 0 is undefined, so total term becomes undefined. So we need a non-zero term in the denominator. So what we'll do? We'll just write 1x into 1 by, find the derivative of f of d. We need to find f dash of d. F dash of d is 2d minus 4, right? 2d minus 4 into e power 2x. Now replace the d by 2. Then we'll get 2 into 2 minus 4. 2 twos are 4 minus 4 is 4 minus 4 which is equals to 0. Right? Since f of 2 equals to 0. Since f dash of 2 equals to 0. So leave this x as it is Again write 1 more x into 1 by, find the derivative of 2d minus 4. Okay, f double dash of d is, derivative of 2d is 2 minus derivative of constant is 0, which is 2, right? 2 minus 0 is 2. So you'll get 2 here into e power 2x. This is equals to x into x. X square into 1 by 2 into e power 2x, which is equals to x square e power 2x by 2. Therefore, 1 by f of t into e power 2x is x square into e power 2x by 2. Now coming to yp, then yp becomes 8 into, result obtained from 1 by d square minus 4d plus 4 into x square is 1 by 4 into x square plus 2x plus 3 by 2 plus, result obtained from the second term is x square into e power 3x, sorry, this is 2x, right? 2x by 2 is equals to 8 ones are 8 twos are. Just multiply all these three terms with 2, you'll get 2x square plus 2 twos are 4 into x plus 2 into 3 by 2. Here 2 gets cancelled, plus x square into e power 2x by 2, which is equals to 2x square plus 4x plus 3 plus x square into e power 2x by 2. These are required yp. Now let's write the general solution. The general solution is given by y equals to yc plus yp. Then y equals to, we have yc and yp, right? Yc is c1 plus c2x into e power 2x plus yp is 2x square plus 4x plus 3 plus x square into e power 2x by 2, which completes the problem. So we have seen a problem from higher order linear differential equations in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.